the equation for relative velocity. Come on. Okay. So this is the velocity of the object relative to the Earth is equal to this vector sum of the object relative to the medium plus the velocity of the medium relative to Earth. All right, so because they're vectors, we can break them up into the x and y components. You could do the z component if you really wanted to, but not necessary. Some of these problems you might have already learned how to do in math class. They probably pitched it to you in a different perspective, but here we go. So if you're able to swim at 4 meters a second in a swimming pool, that's still water. If you jump in the river, the current of 3 meters a second, and swim always pointing perpendicular to the current, how fast will you be going according to your friend standing on the bank? Okay, this problem is easy. You don't need what I just taught you to be able to answer that. You actually answered this question already last year. You're simply finding the resultant velocity. But I want to use this as a simple example. The correct answer is 5 meters a second. You have a 3, 4, 5 triangle. Okay. But I want to show you this in terms of this new perspective. So what is this in terms of object, medium, and Earth? The velocity of what? Yep. This is the velocity of objects relative to the medium being the water. Okay. What is 3 meters a second? Yep. Velocity of the medium relative to Earth. To like a stationary reference point. This is the Earth. Okay. And so what I'm looking for is how fast the person standing on Earth sees me swimming. So I'm looking for velocity of object relative to Earth. That's what I'm looking for. Does that make sense? Okay. So if I break this up into the x and y components, okay, I am swimming this way. The current's going this way. Oh, just kidding. Switch those numbers. So in the x direction, I'm going to say this way is positive and this way is positive. Like this is positive y and this is positive x. Okay. So I've got, I don't know this. In the x direction, I know velocity of the object relative to the medium is a positive 4 meters a second. How fast is my medium going relative to Earth in the x direction?
In the x direction, isn't it the person is on the
Oop. Thank you much. Thank you much. Let's switch this over to the y direction. So positive 4 meters a second plus 0 in the y direction. Okay. So the velocity of the object relative to the Earth in the y direction is 4 meters a second. And over here, you have velocity of object relative to the Earth in the x direction. Your velocity of object relative to the medium in the x direction is 0 plus velocity of medium relative to the Earth is 3 meters a second. So my velocity of the object relative to the Earth in x direction is 3 meters a second. So you can say the object relative to the Earth is equal to 3, 4 meters per second, or finding the resultant of those two, 5 meters a second at whatever angle that is. (53 degrees) low, or 53 degrees, whatever, south of east. Okay with that? Okay, super complicated way to do that problem. Would not recommend it. Okay, just do the way you know how to do. But I wanted to show you something that you're very familiar with this weird, different vector notation. Okay, this vector notation can enable us to solve more complicated stuff. Oh, shoot. Like previously calculated. That is not what we calculated. All right. Doggone it. Well, I didn't calculate that. I solved this problem using our crazy complicated stuff. And evidently I switched gears on myself. I changed the problem. All right, so what I'm trying to do is swim directly across the stream. So if I would have done this, I would have ended up over here, downstream. So what I want to do is I want to change so I'm not swimming directly this way. I want to swim slightly upstream so that I end up going directly across and meeting my friend on the opposite side. I want to swim this. That's directly across at that point. Okay, so I'm swimming. The 4 meters a second is doing something. 3 meters a second is still doing this. And I want my resultant velocity to go straight in the positive y direction. Good with that? Okay, so you might be able to do this intuitively without doing it my way. I understand that, but trying to show you, I'll show you my long way, then I'll show you the easy way. Thank you, Isaac. So I'm looking for that angle. So I don't know this. Velocity of object relative to the medium. So we got 4 times cosine. Sorry, this is going to be -4 cosine theta plus 3 meters a second. And over here, I've got object relative to medium. We got 4 meters per second times sine of theta plus 0. Everybody go to that?
And then you solve that system of equations.
Yep. So no. I know something. One other thing I know. One of these two I know. What do I know? Yep. I want this to be 0.
Because you're lazy and don't just walk up the river to have the current push you where you want to go.
Okay. So right here, I can solve for it. Just with this guy. There we go with that. Okay. To do the easy way, I'm doing head to tail. It's the resultant of these two. That's 3 meters a second. I want the resultant to do this. That's my resultant velocity. So I can just do inverse sine, opposite over, oof.
You might want a calculator. The other side is root 7, so.
Yeah, I'm trying to figure out why there's a disconnect there. Oh, because I messed up my sine. Cosine. No, that shit. I messed up my sine cosine. My x. Oh, that's cheating. Like I'll own it when I mess up.
You see, I'll just.
There.
I would have just swapped theta.
Good. All right. All right. Tell your neighbor.
Sorry for accidentally giving you the speed.
Because that's where you staff wear purple. Like, I got a purple shirt. I can handle that.
What's my class color and
You're green.
What's tomorrow? Holiday hat.
Oh yeah, I didn't wear it.
Okay, here we go. C. All right. So let's say that you want to go at 30 degrees downstream from the location. You could pull this off with this equation. Okay? If you ever get your private pilot's license and you have to like plan your route with wind, that equation that I showed you will be really helpful. They'll probably give you an equation that just came in like, here's the cookbook equation, you just plug stuff in, but that's where it came from. Like, all right. So you can also do this with resultant acceleration. Okay. However, I don't think I've ever seen anything where it's more complicated than one dimension in this class. Like I've never seen, like, for example, an elevator is an accelerated reference frame. Which one is this? Oh yeah.
Is it Tuesday?
Phase two.
It's a really long week.
Thank goodness it's not.
Yep. We're almost there, kids. Almost there.
How close now?
You're right. This is the part of the race that hurts.
No, there's no
The cable snaps. I've been doing more than dropping a rock in the elevator.
Okay. Correct answer is talk to your neighbor.
Okay, so it's a squish cancel. I don't think this happened in real life. They're all like Mario 64 running through.
Yeah, sure. So are you already falling?
Relative to the Earth is also nice.
Yeah. Because if you were to jump in as soon as that, it's also big.
Yeah.
But if you drop it instantaneously as the cable snaps, well, not
That'd be
instantaneously.
cool. Oh,
Right.
it's like a rocket ship. It's like you're dropping it as you're doing it. It would still lose it.
So if you're going faster.
Because if it falls faster.
Oh, true.
They want to fall faster.
So what's the answer to the actual?
Correct answer is E. Just sit there and free fall. That's how the vomit comet works.
You know about the bomb.
The airplane that goes down and you like float inside. Okay. So hold on, let me. Woo, that was pretty intense. Oh no! Oh no! Oh no!
Oh, that was one heck of a vomit comet.
Look a little spinny. And then if you're like,
Yeah, it's basically. Yeah, the little blue cage thing that they plug you in and you push it.
Because he doesn't post the answer. I don't understand. You're not posting answers. Why wouldn't you post the answer? Yeah, and I have no clue. Like, zero clue. So I was like, okay, whatever. I said, can you help me with a question?
Dude,
And he answered me a minute later. It was literally 95.
there's no explanation.
But then a similar question was on the test. I was like, Emma, you're a genius. I was like, I'm a genius. Like,
Okay.
what's the frame?
That is a great question. What?
I think it's other than
I don't know.
AOE equals AOL plus.
Yeah, it's part of it. Yeah.
Oh, Are you talking about overwatching up there?
Yeah. Easy. Dropping over the fact that you're a gatekeeper channel.
Bro, I want Mr. Powell to walk in and strike his street. Yeah, he talked about it for like 20 minutes.
Have you played
Okay, what do you say? Correct answer is B. Here's how it's applied to the equation. Okay, so you are looking for the object relative to the medium. This is what you're looking for. Okay, the medium relative to Earth. This is 9.8. Okay, the elevator is falling. Okay, the object relative to Earth. This is also negative 9.8. This is the rock. Does that make sense? Okay, I'm just trying to show you, like you can probably intuitively do it, but in case that's a struggle, that's how you do the math.
Okay, so I'm going to guess down is negative.
Correct.
Sorry, my bad.
I think this is 0.41% chance I get this right.
Talk to your neighbor. They're very good with C. Okay, so here's how you do the math. You've got this is this is negative 2 meters per second squared. This is negative 9.8 meters per second squared, and you're looking for this. Okay, conceptually, if you were to drop a rock, would it take longer amount of time, shorter amount of time, or equal amount of time that if it was moving at a constant velocity? Does everybody go longer? Does that make sense? It's speeding up away from it. So that would look like you have an acceleration that's less than 9.8. Okay.
Oh no. The rock breaks through Okay, Brad, you
do it on the way up.
Tell your neighbor.
Brad, you don't have very far to go.
Okay, see, every time I get in an elevator, my feet touch the bottom, my head touches the top.
Okay, is everybody good with E? Okay. So when you get into Einstein stuff, he uses this elevator analogy to help to describe why gravity works. It's more of an accelerated reference frame. Okay, but we're not going to use that. We're gonna employ this for conservation of momentum. Okay. Now, when we do conservation of momentum, this has to be done with all our velocities from the same inertial frame of reference, meaning inertial meaning it's moving at a constant velocity or it's at rest. But it has to be consistent frame of reference. Okay, so if we this is not as cool as you think it might be. So this is and this is from the frame of reference of Earth.
Wow.
Okay. Now. Oh no, that's not what I wanted. Hold on. Okay, yeah, let's look at this. This is better. Okay, here we go. This is from the frame of reference of Earth. Okay, so our camera is sitting on Earth and we see it moving. What would happen if we put our camera, our frame of reference, to match the location of the center of mass? What we get is this. For the same experiment, what it looks like is that the location of the center of mass stays the same, and it looks like the two sleds are coming together. Does that make sense? Like if my frame of reference was tracking along here, what I would see is the two carts coming like that.
It's like if I stood there.
If I just stood here and did this,
Yeah. Would it work?
I doubt it. There's too much background.
Yeah.
Like your brain is like, no, I couldn't get there fast enough. Right. I mean, you can try it. I mean, give it a shot. Ready? Here we go. Ready? I'll do it again. Here we go. Oops, just kidding. 1, 2, 3, go.
Oh, but then my head blocks it. Okay.
Probably not. Yeah.
Did it work?
All right. So.
This guy. There's a pile of shots that I carry with cool eyes.
The little massive one.
For emergency.
Bro, that's what's in my backpack.
I don't know why you're so light.
Oh, Lordy.
Ignore errors. Oh, I was so confused.
You get pretty good at You got one big shot, but there's half shot.
I like how he's just kind of throwing it like a baseball too. Yeah. That's how they get around because they're actually on roller skates all the time. They just have to bat a shot.
They just want to die of mind part.
Okay, tell your neighbor.
Really? Actually, if I get COVID, you for my final.
I hope you do.
Our multi-V finals partner.
I know.
We should do a group final.
We were not gonna do it. So worth it.
Smiley, their finals are partner finals. We should do.
No, not a chance. All right. Correct answer is B. Bountiful buffaloes. All right.
Brad, I have a good idea. Call me over the weekend and yell at me to study.
No. If that's what you need, then you lost.
Because like I'm genuinely nervous. I'm gonna be like, you know what, screw up.
It's just the last chapter. I just have no idea.
Nobody has any idea.
Here we go. Here we go.
Oh, someone on another card. It's like a 70s cartoon.
I'm literally on my phone. There's like 5 people in it.
I mean, yeah, you know.
But the less you
One
listen,
of them,
the
yeah,
more.
one of them's
Wait, are they moving in the opposite direction or the same direction?
Same direction.
Brad, here, I have a good idea. You take my house final. I'll take your spot.
Here we go. Here we go. Here we go. Got a lot of words.
Well, half of them are dropped. And then there's none of you.
Tell your neighbor.
Physical velocity relative to 0, so.
Here we go with an A.
That's why they have a lot of shots.
Relative mass is 0.
Okay.
I personally think it's supposed to be the relative mass.
I know. Oh, tricky.
Ask for help. You know. Usually you don't have so much trouble with problems in the work for some
I know what flex is. So flex goes into the board. But then there's some.
Thumbs up when you have a
You have
guess.
to change it and it goes out because you're
Have a
changing flex.
conversation.
So
How's the weather pass?
C, because you're moving 2 meters per second to the right and the other one is 20 to the left, so you can put them. It looks like it's going fast because you're going by. You know when you're.
Okay, you're gone. You're gone.
If I'm going vroom in a car this way and another car goes vroom by me, it looks
Oh,
like
but
he's
you
going a
throw
lot
it
faster
20.
than he is.
And then
I'm pretty sure Ray's talking to them.
Those darn police always on the other side of the road.
See.
I'm sure you could have been behind me. I would've been-
Correct answer is. Everybody okay with C? Oops. Same scenario.
You and Carter got it.
No.
It's like enemies before. One of those up there.
It makes it funnier, right? It says, oh, well, you can eliminate 2 of them. And everyone's like, yeah, you can eliminate 3 of them.
Could have let me 4, but you have to. None of these are right.
Tell your neighbor what the right answer is. There we go with C. All right.
We didn't do any calculus though.
Now you are correct. We're not doing calculus today. All right. So, let's see, what do we change here?
So guys, I was shot putting on my car. Bought a bunch of coconuts at Walmart.
Remember that time I was on top of a mattress, on top of a truck going to church?
Coconut shot.
All right, so the velocities were not the same. Okay. Are they contradictory? Is it possible to have different momentums depending on your frame of reference? Yes. Which is a little crazy. Okay. So, all right. So here we go. We're diving deep. Ready? Yeah, we're good. We got 15 minutes. All right. Conservation of momentum is only true if you have the velocities are from the same frame of reference, same camera angle. Okay. So here is how they'll pitch a problem. Relative to you.
It seems pretty arbitrary to me.
All right, so this is the problem that we're going to solve. Okay. Yeah. So, which setup is it going to be?
It's genuinely good. Not genuinely bad.
I genuinely understood. But unless Freddie doesn't call me it.
I know that
I'm genuinely so stressed.
Okay. All right. So does everybody see the conundrum?
No.
Okay, this is given 20 meters a second relative to you, and the 2 meters a second was given relative to Earth. I want the frame of reference to be from the Earth. So, is everybody okay that this is not the right answer? Okay. So, this is where this comes in. Okay. I want this. Okay. What is 20 meters a second? Where's 20 meters a second on this? This is negative 20 meters a second here. What is this? This is 2. Oh, just kidding. Hold on. No, it's not. No, nothing relative. Okay, is this 2 meters a second, or is it the speed at which you're going after it's thrown. Or is that the same thing?
I see. That's the.
Say that again.
Is this the velocity? Is this 2 meters a second? Or is this the velocity of the cart after you've thrown it? Is the cart still going? Is the cart still going 2 meters a second? No. So this is some unknown. Turns out that same unknown is what we're looking for. No, not a trick question. Just a tricky question. Okay? So the correct answer is B. Okay? Because this is the velocity not before it was thrown, but after it was thrown. That's how fast it looks like relative to the cart after it was thrown.
Oh.
Do you see that like that? That'll get you.
It's still getting me. That's the velocity.
Okay? So that's our setup. Okay? And so here we can solve. So we have 295V plus 5V minus 100. So I got 300. Oh, so nice of me to make my life easier. This is great. 3 meters a second. Okay? And this is relative to Earth. You good with that? Cart relative to Earth. Okay?
Should be 3.14.
All right. So let's look at this from a frame of reference of from the cart moving along at 2 meters a second. So everybody go to a C. Okay.
You can eliminate two immediately.
Tell your neighbor. Correct answer is. The answer is B. Because this is you're still moving at 2 meters a second. The frame of reference is moving along there. The velocity of the cart is now more than 2 meters a second after you throw it. So this 20 meters a second is in reference to relative to how fast the cart was moving with 2 meters a second plus whatever is going. So you still have to take into account that. Okay, good with that? So yeah, we'll do this. All right, so just to like to bring it home here, we got 95v plus 5v minus 100. So v is equal to 1. Is everybody all right with that? That's the velocity. This is the velocity of cart relative to moving at 2 meters a second. Good with that? That moving frame of reference. So we will pick this up tomorrow for some crazy applications.
Great. So if you have a binary star system, you throw a shot put off of it.
No, it's gonna be like a spaceship, but we're gonna drop our boosters off the side.